All right, we're going to look at tangent lines and circles today. All right, so here's our circle O. I'm a little closer for you to see. And line AB is a tangent. And what that means is that this line, which could also be a segment or a ray, doesn't matter which one, hits the circle in exactly one point on the circle. It doesn't go through it. Any line that goes through the circle is a secant. So this is our tangent. Okay, that's a tangent line. Hits at one place. A line like this is called a secant. If it's just a chord, it would only connect two endpoints, and that would be our chord, right, which you have some knowledge in already. All right. So those are the differences between the types of lines, rays, or segments that would intersect a circle. So today we're going to focus on tangent lines. So in our second example, we have a radius, OP. Okay. If a tangent line intersects a radius on the circle, it forms a nice right angle. Part of that right angle is inside the circle, and part of it is a little bit outside the circle. Okay. That's important for us because we're going to be dealing with some right triangles now that are going to be created between tangent lines and radii and other segments that are coming in or out of the circle. So here's our first problem. Okay, we have that ray AB, okay, is tangent to circle C. If you want, you can name this. We'll put a D out here just so we have something to name it. All right, and what we have then, because this is tangent to the radius AC, that's our circle name, so we know that's the center, drawn to there is our radius, we have a nice 90-degree angle. So what we have is 58 degrees, 90 degrees, and we need to find x. So we're back just to simple triangles, okay? So we take 90 plus 58, that's going to equal to 148, and we subtract 148 from 180, and we get 32 degrees. Another way to look at it is if 90 degrees is here at our right angle, then the other two angles have to make up the difference of 90 degrees. All right, so if 90 minus 58 would also give us 32. All right, so x equals 32 degrees. All right, our second problem here, okay, is that segment AB is tangent to the circle. It doesn't extend beyond it, but it's tangent, so we have a nice right angle here also at angle A. So we want to find x, which is our central angle. So we have 90 plus 22 equals 112. And we have 180 minus 112, which equals to 68 degrees. So x equals 68 degrees. The alternative is, if that's 90, 22 plus x equals to 90 also. So 90 minus 22 would also give us 68. So that's how you work with tangents. That's a special, unique thing that tangents give us when intersecting with a radius. Nice 90-degree angle. All right. Now, that's for angles. Well, what if we have to find out side measures? Well, we have ray AB is tangent to circle O. We see here, this is 3 units, which means this is 3 units because they're both radii. So you're going to have to keep your eyes open for that, all right, because it's a little tricky. This piece outside of our segment outside our circle, that's 7. So all together, this side is 10. And we need to find the segment from A to B, which is part of our tangent ray. Okay, so we're going to take the fact that our radius and our tangent make a 90-degree angle. So this 10 is our hypotenuse. 3 and x are A and B. So 3 squared plus x squared equals 100. Well, 10 squared, so 100, all right? 9 plus x squared equals 100. I'll make that 10 squared in case anybody gets like freaked. All right, minus 9, so x squared equals to 91. Take the square root on each side. This is positive and negative, but we only want the positive because it's a length. So x equals the square root of 91. And depending on what problem you're working on and what they want you to round to, then you round accordingly. I'm going to round to nearest hundredth. So this comes out to 9.54 units. All right. Okay, so now we're going to look at a theorem about tangent lines. Okay. If two tangent segments or rays or lines intersect a circle at a point of tangency, then the segments from the point of tangency to a point outside where these two tangent lines meet are equal. Okay, so segment AB is equal to segment AD. So we'll mark that. Now, the cool thing is, look, if we have radii that come in here, whatever they are, they're equal also. So we can find out a lot of information about our quadrilateral, okay? And we'd be able to find angles here at the central angle or possibly the angle outside. So let's take a look at this circle. It's an inscribed circle, all right? So what we know is that this tangent here, okay, from here to here, is equal to this tangent. I'll keep them in blue, and I'll mark them as that, all right? The tangent here is equal to that part, and then our last part, which is in pink, will be equal to each other, okay? Now what we have is we have a whole length here of 8 and an entire length here of 9, and we need to find z and x. And I think I have a y on here. We'll have to find y also. Okay, so since these two tangents are equal, x equals 6 right away. I'm going to put that on here. Now, because this entire length is 9, that means the rest of it is 3. So if this is 6, this is 3, which means that y is equal to that tangent, which is also 3. Since this entire side is 8, then the rest of this has to be 5. And since this tangent equals to x, then x is 5. Okay? All right, so that's how you work with these. And I know we did a little bit of this once before, but here you go again. All right? That was a little close-up for you. All right, so let's look at this one and see how we find x, y, and z. And then we want to find the perimeter of the polygon. All right? Okay, so let's start marking. These are equal. I do it in color, it's a little easier. These are equal. And these are equal. All right, so right now we know that z is 4 because those two tangents are equal. We know that x is 3 because these two tangents are equal. And we know that y is 5 because these are equal. So we want the polygon's perimeter. We're going to add them all up. All right, so this is 7, this is 8, and this is 9. Okay, so that's 17 and 7, so 24 units. All right. So take your time doing those to mark them up and have to write the answers on the figure so that you can see them. All right, now, what we know also is what we said before is that these tangents form an external angle. All right, and that external angle we'll be able to find pretty easily because we have two radii here which form nice 90-degree angles. All right, so with that we have 90 and 90, which is 180, plus 130. In a quadrilateral, there's 360 degrees. So 90 and 90 plus 130 is 310. So we have 360 minus 310, and that equals 50. So angle X is 50 degrees. All right, now, a little tricky, but be careful. Now we want to find sides. We want to find the radius here, X. This part here is X also because that's a radius, and that part's outside is 2. So this entire thing is X plus 2. This is a 90-degree angle meeting here at our tangent and our radius. So what we've got is our 8 squared plus x squared, which is this x here, plus, equals the quantity of x plus 2 squared. So we have 64 plus x squared equals, FOIL this, it's x squared plus 4x plus 4. Subtract the x squares, and they will drop out for you. If they don't, then you have a quadratic equation, and you'll have to factor it accordingly and find your x values. But most of the time, these work out this way. But if that were to occur, just keep that in mind. So subtract 4, and we get 4x equals 60, and x equals 15. All right, so that's how you'll find your radius. Again, if this works out to be a quadratic, you'll FOIL it. This part, you'll factor by get everything over to one side equals 0, factor it, and whatever values for x, you try them and see if they will be valid. If they come out negative and it's a radius, then it won't work because you can't have a negative length. Okay, so sometimes only one of the answers will work. And that is how you work with tangents to a circle.